There is a chip that was never supposed to exist, not because the physics was impossible, not because the engineering was beyond human capability, but because an entire coalition of governments decided, publicly, legally, with the full force of export control law, that this chip would never be manufactured. They cut off the factories. They cut off the software. They cut off the design tools. They cut off the people. And they said, that is it. That is the ceiling. You will not build the future without our permission. And then Huawei said, watch me. Right now, this very moment, a new AI processor is going live on a cloud platform in southern China. It was designed in Shenzhen. It was manufactured on Chinese soil. It runs Chinese software. It serves Chinese AI models. And it does all of this using a process node and an architecture that the sanctions architecture was specifically, explicitly engineered to prevent. This is not a rumor. This is not a prototype sitting in a lab waiting for funding. This is commercial deployment. Live workloads, real customers. Today. And if you want to understand how the global AI race just split into two parallel tracks that may never merge again, you need to understand what this chip is, how it was built, and why every assumption the West made about technological containment just evaporated. If this kind of deep dive is what you came here for, hit subscribe. It genuinely helps, and the next few years are going to produce one story like this after another. Let's get into it. To understand why this chip matters, you need to understand the world it was built in. And that world had one rule above all others. If you wanted to train a serious AI model, not a chatbot, not a recommendation engine, but a frontier model with hundreds of billions of parameters, you needed one thing: NVIDIA silicon. Specifically, you needed H100s or their successors, and those chips were manufactured by TSMC in Hsinchu, Taiwan, using extreme ultraviolet lithography made by ASML in the Netherlands, with design tools from Cadence and Synopsys in California. That was the pipeline. That was the only pipeline. And every single AI lab on Earth, from OpenAI to Google DeepMind, to Meta, to every startup with a Series B, was plugged into that one pipeline. No exceptions, no alternatives, no backup plan. Now, to be fair, NVIDIA earned that position. Their CUDA software ecosystem was 15 years deep. Every major AI framework, PyTorch, TensorFlow, JAX, was optimized for CUDA first. Every research paper, every training recipe, every inference optimization was written assuming NVIDIA hardware underneath. It was not just a chip, it was an ecosystem, a gravity well, and the switching cost was enormous. But here's the hidden cost that nobody talked about until the geopolitics turned sharp. That pipeline had a kill switch, and the kill switch was not in Taipei. It was in Washington. When the United States imposed export controls on advanced AI chips to China, it was not a trade dispute. It was an architectural decision. The decision was this: China's AI development will be capped. It will be allowed to build applications, to build models that use existing architectures, to build products, but it will not be allowed to train the next generation of frontier models. Because without the hardware, you cannot train, and without training, you cannot compete. The logic was clean. The execution was brutal. NVIDIA A100s, banned. H100s, banned. Even the deliberately nerfed China-specific variants, banned. TSMC manufacturing for Chinese AI chips, banned. EDA design tools from American companies, restricted. And the enforcement was not just on paper. Shipments were intercepted. Companies were fined. Intermediaries in Southeast Asia were shut down. The message was unmistakable. You can have AI, you just cannot have the best AI. Not unless we allow it. And for a while, that looked like checkmate. China's AI labs had stockpiled some NVIDIA chips before the bans, but stockpiles run out. And you cannot train the next frontier model on last generation's hardware forever. The gap compounds. Every year you are frozen, the frontier moves further away. This felt like a problem with no real solution, until one company decided that the problem was not the chip. The problem was the dependency. So here's the question everyone asked. And it was a fair question. If China has the second largest economy on Earth, the most engineers, the most aggressive industrial policy, why could they not just build their own AI chip? And the answer, for years, was they tried, and they failed. And the reasons they failed are instructive. Because building an AI chip is not one problem. It is 4 problems stacked on top of each other, and each one alone is hard enough. Problem 1. Architecture. You need to design a processor architecture optimized for the specific math of neural networks, matrix multiplications, tensor operations, massive parallelism. This is not a general-purpose CPU problem. It requires a fundamentally different approach to how you organize compute and memory. And the dominant paradigm, NVIDIA's GPU architecture with CUDA on top, had a 15-year head start. Problem 2. Manufacturing. Even if you design the perfect chip, someone has to physically build it. And the most advanced AI chips need the most advanced process nodes. 5 nanometers, 3 nanometers, and those nodes require EUV lithography, which means ASML, which means the Netherlands, which means the Western Coalition, which means no. Problem 3. Software. A chip without software is a rock. You need compilers, you need drivers, you need framework integrations, you need developers who know how to write for your hardware. And CUDA had 15 years of accumulated developer knowledge. Every Stack Overflow answer, every GitHub repository, every university course, all of it assumed NVIDIA underneath. Problem 4. Yield. Even if you solve all 3 of the above, you need to manufacture the chips at scale, with acceptable defect rates. And when you are pushing process nodes without access to the best lithography tools, your yield drops, your costs spike. Your chips are more expensive per unit of performance than the thing you are trying to replace. 4 problems. Each one alone enough to kill a program. Together, they formed a wall that looked unclimbable. And for years, that wall held. Huawei's first Ascend chips, the 310, the 910, they existed, they shipped, but they were behind, a generation behind, sometimes 2. The software was rough, the developer ecosystem was thin, the performance per watt was worse, and the manufacturing was constrained to older process nodes because the advanced ones were locked behind export controls. The Western assessment was consistent and, frankly, not unreasonable. Chinese AI chips are a domestic fallback, a political project. They will serve the low end. They will never compete at the frontier. The gap is too wide. The ecosystem is too deep. The manufacturing constraint is permanent. That assessment held for years, and then it didn't. Here's the twist. And this is where the story shifts from China tries and fails to China reframes the entire problem. Huawei did not try to build a copy of NVIDIA. They did not try to replicate CUDA. They did not try to match TSMC's 3 nanometer process using equipment they do not have. They went sideways on every single axis simultaneously. Let me walk you through it, step by step. Because the elegance is in the system, not in any single component. Step 1. The architecture. Huawei built what they call the Vinci architecture, and the key insight is this. Instead of trying to make a GPU that happens to be good at AI, they built an AI-native processor from the ground up. The Vinci core is organized around what they call cube units, dedicated matrix multiplication engines that process 3-dimensional tensor operations natively in hardware. Not as an afterthought, not as a bolted-on accelerator, as the fundamental compute primitive. Think of it this way. A GPU does matrix math by breaking it into thousands of tiny parallel operations across many small cores. It works, it is flexible, but it carries overhead. The Vinci cube unit does the entire matrix multiply in one shot. One instruction, one cycle for the core operation. That means less wasted energy on instruction decoding, on memory addressing, on coordination overhead. You get more math per watt. And for AI training, where you are running the same matrix operations billions of times, that efficiency compounds. Step 2. The manufacturing. This is the part everyone said was impossible. You cannot build advanced AI chips without EUV. You cannot access EUV. Therefore, you cannot build advanced AI chips. QED. Except Huawei's manufacturing partner, SMIC, Semiconductor Manufacturing International Corporation, based in Shanghai, found a workaround. They used deep ultraviolet lithography, DUV, the older technology, with a technique called multi-patterning. Instead of 1 exposure to define a feature, you do 2, 3, 4. You expose, shift, expose again. You build the fine features by overlaying multiple coarser patterns. Is it as efficient as EUV? No. It costs more per wafer. The yield is lower. The process is more complex. But it works, and works is the entire point. The sanctions assumed that without EUV, China would be locked out of sub-7 nanometer manufacturing. Multi-patterning DUV broke that assumption. Not elegantly, not cheaply, but irrevocably. Step 3. The software. This is where Huawei made the boldest bet. They did not try to make their chip CUDA compatible. They built a parallel ecosystem. They call it CAN, Compute Architecture for Neural Networks. It is their equivalent of CUDA, their compiler stack, their operator library, their framework integration layer. And here's the brilliant part. They made it open. They open-sourced their AI framework, Mindspore. They built adapters so that PyTorch models can be ported to Ascend hardware. They invested in making the developer experience as painless as possible, knowing that the single biggest barrier to adoption is not the silicon. It is the switching cost for developers who have years of CUDA muscle memory. Step 4. The system integration. The 950DT is not just a chip. It is a node in a cluster architecture. Huawei designed a high-bandwidth interconnect, their equivalent of NVIDIA's NVLink, that allows hundreds of Ascend processors to be networked into training clusters. And they designed the entire stack: chip, interconnect, server, rack, cooling, software, as one integrated system, not assembled from parts, designed as a whole. And here's what makes this different from every previous attempt. Previous Chinese AI chips solved one of the 4 problems, maybe 2. The 950DT addresses all 4 simultaneously: architecture, manufacturing, software, system integration, and it does so at a performance level that Huawei claims is competitive with NVIDIA's data center offerings for specific AI workloads. Not identical, not across the board, but competitive. In the workloads that matter most for the Chinese AI ecosystem: training large language models, running inference at scale, serving cloud AI products. That is not a marginal achievement. That is the wall coming down. But architecture diagrams and press releases are one thing. Commercial deployment is another. And this is where the story stops being theoretical. The Ascend 950DT is not sitting in a lab. It is going live on Huawei Cloud. Commercial customers, real workloads, training runs, inference serving. The Huawei Cloud Vice President confirmed the deployment timeline publicly. This is not a roadmap slide. This is silicon in racks, processing tokens, generating outputs, serving end users. And it is not one data center. Huawei has been building Ascend-based AI clusters across China, government-backed AI compute centers, university research clusters, enterprise deployments. The Chinese government's own AI infrastructure build-out has been oriented around domestic silicon, not as a preference, as a requirement. Think about the scale of that. China's national AI compute strategy, the backbone that will train the next generation of Chinese language models, power Chinese autonomous driving, run Chinese scientific AI, is being built on Ascend, not because it is the best option available globally, but because it is the option that cannot be turned off by a signature in Washington. And the investment numbers behind this are staggering. China's semiconductor self-sufficiency push has channeled tens of billions of dollars through the National Integrated Circuit Industry Investment Fund, the so-called Big Fund. Phase 3 alone targeted over $40 billion in new capital, and a significant portion of that flows to AI chip design, advanced packaging, and the manufacturing ecosystem that supports chips like the 950DT. Huawei itself has poured billions into R&D. The company spends over 20% of its annual revenue on research. In absolute terms, that puts them among the top 5 R&D spenders on planet Earth, and a substantial fraction of that goes directly into the Ascend line. Architecture iterations, process optimizations, software development, cluster engineering, and the talent pipeline is not theoretical. Huawei employs tens of thousands of chip design engineers. SMIC employs thousands more in manufacturing. The Chinese university system graduates more electrical engineering and computer science PhDs per year than the United States, Europe, and Japan combined. The constraint was never talent. The constraint was access. And access is what the sanctions removed. And access is what China rebuilt, painfully, expensively, but completely, from the ground up. The ecosystem is compounding. Mindspore, Huawei's AI framework, is now used in thousands of enterprise deployments across China. The CAN software stack has been optimized for the specific workloads that Chinese AI companies actually run. The developer community is growing. The documentation is improving. The tooling is maturing. Every month, the switching cost drops a little further. And here's the strategic logic that makes this irreversible. Every model trained on Ascend hardware, every inference pipeline optimized for CAN, every developer who learns MindSpore instead of CUDA. That is one more node in a parallel ecosystem that does not need NVIDIA, does not need TSMC, does not need American EDA tools, does not need anyone's permission. The sanctions were designed to create dependency. They created independence instead, and independence, once achieved, does not voluntarily reverse itself. But here's the honest part of this story, and I want to be straight with you, because this channel does not do hype. The 950DT is not NVIDIA's equal across the board, and pretending otherwise would undermine the very real achievement that it represents. The manufacturing process, multi-patterning DUV, is more expensive per wafer than EUV. The yield is lower. That means each chip costs more to produce. And at scale, cost matters. It determines whether you can deploy 100,000 chips or 10,000, whether your cloud AI is price competitive or subsidized. The software ecosystem, while growing rapidly, is still thinner than CUDA. 15 years of accumulated developer knowledge, Stack Overflow answers, GitHub repositories, university courses, optimized kernels. That depth is not replicated overnight. A developer porting a complex PyTorch model to Ascend will still hit rough edges, operators that are not yet optimized, edge cases that CUDA handles gracefully but CAN does not. This gap is closing every quarter. But it is not closed yet, and the process node, even with multi-patterning, is behind TSMC's leading edge. The 950DT is not manufactured at 3 nanometers. It is manufactured at a node that achieves similar transistor density through brute force patterning, but with higher power consumption per transistor. That means for the same workload, an Ascend cluster may draw more power than an equivalent NVIDIA cluster. In a world where AI data center energy costs are already a strategic constraint, that matters. So no, this is not the moment where Huawei replaces NVIDIA globally. That is not what happened. But here's what did happen. The kill switch is gone. The assumption that China's AI development could be permanently capped by hardware access, that assumption is dead. The 950DT does not need to be the best AI chip on Earth. It needs to be good enough to train the next generation of Chinese AI models. And it is. It demonstrably is. And good enough, plus cannot be turned off, is a different strategic equation than best but dependent. The first equation compounds. The second one collapses the moment permission is revoked. None of this erases the real engineering gap that still exists. It simply marks the distance between impossible and inevitable. And that distance turned out to be shorter than the architects of the sanctions wanted to believe, which brings us back to the bigger picture this whole story has been building toward. Because this is not really about one chip. It is about what happens when you try to contain a civilization-scale engineering effort by cutting off its access to tools. The bet was simple. Cut off the factories, and the designs stay on paper. Cut off the software, and the hardware sits idle. Cut off the talent pipeline, and the knowledge atrophies. And if you do all three simultaneously, with the full weight of allied export control regimes behind you, the contained party will plateau. They will build applications on top of your stack. They will be users of your technology, but they will never be builders of their own. That bet lost. Not because it was stupid, not because it was poorly executed. It lost because the assumption underneath it was wrong. The assumption was that complexity is a moat, that the more complex a technology, the harder it is to replicate, and therefore the longer the monopoly lasts. And for a while that holds. But complexity also means more people, more institutions, more accumulated knowledge distributed across more nodes. And once a country decides that replicating that complexity is an existential priority, once it mobilizes the full apparatus of state, industry, and academia toward that single goal, the timeline compresses, the learning curve steepens, the impossible becomes expensive but doable becomes done. China did not build the 950DT because it was easy. They built it because the alternative was unacceptable. And that kind of motivation, the motivation of a nation that has been told it cannot have something, is the most powerful R&D funding mechanism ever devised. More powerful than any venture capital round. More powerful than any government grant. Because it does not have a discount rate. It does not have a portfolio strategy. It has one goal, pursued with one intensity, for as long as it takes. And now we are watching the result. 2 AI stacks, 2 chip ecosystems, 2 developer communities, 2 cloud platforms that do not talk to each other, 2 training pipelines that do not depend on each other, and two strategic logics that no longer require the other's permission. The world that ran on one AI supply chain didn't announce its own ending. It just started losing ground to something that was never supposed to exist. So here's the question I want to leave you with, and I genuinely want your answer in the comments. In a world with two AI stacks, one built on NVIDIA and TSMC and CUDA, one built on Ascend and SMIC and CAN, which one do you think iterates faster over the next decade? The one with the 15-year head start and the global ecosystem? Or the one with the existential motivation and the domestic market of 1.5 billion people? Because the answer to that question shapes which civilization writes the rules for artificial intelligence. Drop your answer below. I read every single one. And if you want to be here for the next time something impossible comes out of a Chinese fab, hit subscribe. We are building something here, and the next few years are going to be the most consequential decade in the history of computing. You are going to want a front row seat. I'll see you in the next one.